9, so we're going to go back over it. So we're going to look at A, where do we use them and why do we use them and where do they come from, and B, how do we use them? All right? And then over the course of next week, we are going to look at situations where you can't use the trig ratio, but you still need the same sort of information. Okay? And so in other words, we're going to be looking at situations that are not right angle triangles. How do we deal with that? Okay? And as I mentioned to you earlier, this is the extension stuff. Okay? This exact thing that we're doing here, while it's in year 10, it's also revisited in year 12 methods. Okay, it's also done a little bit in general maths in year 11. So it's in different areas of the senior curriculum. So you'll see it in general maths, you'll also see it in methods. So whichever area you go into, you're going to come back to this. Okay, trig is used in all three, essential, general and methods. The basic trig of what we're covering today. Okay, so it doesn't matter where you intend to go next semester and into next year, you're going to come across this. If you go into the real world, you're going to use trig. Whether you realise, or in some areas, not obviously, if you go and work in a shop and you decide to be a retail assistant, you're probably not going to use much trig. If you go to outfit the shop, then you will. Okay, so let's talk about trig. Trig means, what does trigonometric mean? What's the word? Does the word come from? Triangles. Okay, trigonometric is so it's geometry of triangles. Okay, so in order for us to use these ratios, okay, we need to have a triangle. So the first triangle we need is a right angle triangle. Second thing, what are they? What are they? What are trigonometric ratios? Okay, so that's what we've labelled them. Yep, 100%. We've labelled them sine, cosine and tangent. But what do they actually do?
Find the side of the triangle.
Good, okay, so that's what they allow us to do. So a sine, so we've got three, whoops, helps you be able to, okay, there we go. Okay, so we've got three ratios. Okay, we've got sine, we've got cosine, and we've got tangent. Okay, now we shorten those to sin. So we say, what's the matter? You good? Yes, but not with these ratios, and I'll explain that later. Okay? So, not today though. So we shorten cosine to cos, and we shorten tangent to tan. Because we're lazy. Okay? Are any of those words unfamiliar to you? Cool, that's good. What are they? What are they? So what's sine? That's fine. Don't expect, that's why we're going over it, mate. It's all good.
Side angle opposite. Side opposite.
Okay. Yes, okay, so let's dig into that. So, right, does that look familiar? Sokotoa. Yeah? Okay, so let's dig into one of them. Let's dig into the sine one first, just because it's on the top, right? So, what does it mean? What's the S? Okay, sine, yes. I couldn't hear if you're saying side or sine, so I just wanted to clarify. Yep, so the S is sine. What's the O? Opposite. Opposite what? Opposite what? Opposite lock? Opposite what? What is it a measure of? No, side. It's the opposite side. All of this is important, and you're probably going, oh yeah, that's, yeah. But I need it, I'm going to try and be as really pedantic as possible, because an understanding of these ratios helps you actually use them. Okay? So it's opposite side, and what's the H? Hypotenuse. And what is the hypotenuse?
The longest side.
The longest side on a right angle triangle. Opposite the? Right angle. Cool. What's missing in that? I'm just going to move this. Nope.
The little circle with the swirl.
The little circle with the swirl. Oh, hang on. What's that?
The angle.
Good. Theta is what it's called, but it represents the angle. Both correct. Okay? Now, what else is missing?
Equal sign.
Equal sign. Very good. All right. Did you just dab? You just dabbed. That's embarrassing. All right. So we've got a ratio. So this is the idea of where the term trigonometric ratio comes from. A ratio is a comparison of two things that are equal, or two things of the same unit, I should say, not equal. Two things of the same unit. So the opposite side and the hypotenuse are both sides, okay? The ratio of those means form a fraction, one divided by the other. That's the ratio part, okay? And that ratio, opposite side over hypotenuse, is equal to this mystery thing called sine, the sine of theta. Okay? Now, I'm going to guess that you don't actually know where the sine part came from. Is that a reasonable guess? Yep, okay. So let's explore that just a little bit. I don't want to spend a huge amount of time, but if I explore sine, take it for granted that the cos and the tan follow the same idea, just with different ratios. Is that okay? Yep, okay. So what I'm going to do is I'm going to pull into this particular little app. Okay, hopefully it'll come up nicely for me. Okay, so I want CD. Oh, CB, sorry, BC. And I want sine. So we know sine is opposite, so that's AC. So I want to show those two, and I'll show those two as well. Okay, so as you can see, I know it's not very large, so I'll try and make it a bit bigger. Apologies for that. Okay, all right, so what we've got here is we've got two triangles. Now, first question is, are they similar triangles?
Yes.
How do you know?
Because let's start back on.
Good. Right angle?
Side angle, side angle.
No. Back to where you were. Right angle? Do they both have a right angle?
Yeah.
Good. Are the hypotenuses in the same ratio?
Yes.
Well, they have a ratio, yes. What about the opposite sides? The 1.73 and the 0.87. Are they in the same ratio as the hypotenuses are?
Yeah.
Just quickly on your calculator, what's 1.73 divided by 0.87? Approximately. It's close. Is it close?
It's 0.875.
Yeah. So it's not exact, but it's...
Close enough.
Yeah, it's close enough. And these numbers are rounded off, okay? So it's close enough to 2, yes? Yeah, okay. So we've used, first of all, we've proven that they're similar triangles using the RHS. There's a right angle, the hypotenuse of the same ratio as or the similar sides, and the corresponding sides are similar, and another side is, okay? Right here, so, could you please, with your calculators, right, so everyone needs their calculator in front of them. This is, all you're going to be doing is pushing buttons, you don't have to write anything, okay? Could you please use your calculator for me? In the large triangle, so the left-hand triangle, could you do the ratio opposite divided by hypotenuse? Just put that in your calculator for me. So opposite side divided by the hypotenuse.
Is that 1.73?
Yes, it is. I wish I could. Okay, yep, it's 1.73 and 2. Okay, could you just do that ratio for me? What do you get? 0.08.
0.865.
Okay, so the two decimal places, that's 0.87? 0.87, yeah? Okay. Quite obviously it's going to be the same for the other one because it's 0.87 divided by 1. So we've got the same ratio. Are we comfortable with that? Yeah? Okay. On your calculators, now before we go any further, actually I'll pull this up now so we can have a look. All right? So, Jack, catch. Anyone else not have a calculator sitting in front of them? I won't throw quite that far, but I know you can catch it. Thank you. Anyone else not got a calculator? Beautiful. Could you please check on your calculators before we go any further that up in the top where your screen is, that you either have DEG or just a D. If you have an R or a G, or an RAD or a GRA, could you please let me know? You have an R, right. We have to fix that. It has to be in with a D. D?
A DRD.
It's not okay.
It's not okay. But my D's highlighted.
That's it. Okay, that's all I want to know. Cool. Yes, that's fine. Molly, that's fine. No. All calculators are slightly different, so thank you for that information, right? So, does anyone not have the D? The D stands for degrees. Now, if you do choose to go into method specialist, you'll learn about what the R is. It's a different way of measuring angles. Those of you going into the Army or any of the armed forces, or you're doing reserves, the G is gradients, and that's how the armed forces use maps to look at directions and distances. Okay, so they are there for purposes. We don't do G's or gradients at this school, or any school for that matter, but we do degrees, and you will use radians if you go into method specialist, right? But for us, in our course, we just focus on degrees. So make sure that you're calculating degrees before you start. So, could you please on your calculator type sine 60 and execute it or equals it, whatever it comes to. Tell me what you get, please.
60.
Sine 60. Sine 60 equals. So, you recognise that number?
It's on the board.
Think about the ratio you did a minute ago. Is it sine 60 equals? Yep.
Oh, because that's the degrees on that.
Yep. Okay, so notice I've got 60 degrees in my triangle. So, let's play a little bit. Okay, I'm just going to change I'll just move this out of the way for a moment. Okay, I'm just going to change my triangle. Which can I move here? Okay, I'm just going to move. I don't want 6. Oh, here we go. That's what I want. That's what I want to change. There we go. Okay, I'm going to pick a different value. Okay, boys. So, again, the numbers are quite small. We've already identified that they are similar triangles. We're not going to go through that process again. So here's my opposite side is 0.5. My hypotenuse is 1.18. Could you do that ratio, please? So 0.5 over 1.18. So 2 decimal places, can you just jot that number down so you don't forget it? Just the 2 decimal places.
You can't round off.
Mine's an error, so.
Get it all clear, do the division again, Molly. It's just a division. 0.5 divided by 1.18 equals.
Would you do with this game?
Is it still happening or not, Molly? Good, okay. Can you now do from the second triangle, 0.25 and 0.59, same ratio. Can you write that down to 2 decimal places, please? It's 0.25 and 0.58. Can you just jot those numbers down to 2 decimal places as well, please? So they're the numbers off my triangles, 0.5, 1.18, 0.25, 0.59. What do you notice about those two?
They're all the same.
They're almost the same. The 2 decimal places, are they the same?
Yeah.
Yes, okay? Now, I'm only going to 2 decimal places because that's the maximum I've got in my diagram, okay? If we got more accurate in my diagram, I could go to more decimal places. Okay. So what I've found here is, you'll notice that both of these triangles have a 25-degree angle as our focus angle, right? So these are similar triangles. They both have right angles in them. They both have 25 degrees, which by conclusion would mean that those 2 angles at the top are the same as well. So AAA, right? So these are similar triangles. So all triangles with a 90 degrees, a 25 degrees, and a 65 degrees are all similar. Are we okay with that? Yep. So it doesn't matter how big or small those triangles are, as long as they have those 3 angles in them, they're going to be similar triangles. So if I do the ratio, opposite over hypotenuse, doesn't matter how big or small that triangle is, because they're all similar, that ratio is going to be the same thing. Is that fair enough? So you get a number. So your calculator has a number on it, right? Now, what you have to realise, and you cool? Now ask your question, please. To all of us, so I can hear it. What's your question? It may not be.
No.
Okay, are you good now?
Yeah.
Beautiful, thank you. I want this to be clear, so if you have a question, just ask. I don't care. All right? So, back before scientific calculators were on the scene, right? We could do those divisions, and you could do those divisions for a number of decimal places. All right, after a while it gets a bit stupid. So what they did is they created this idea of a trigonometric ratio. So what they did was for each angle, so let's start, you can start at 0 for angle 1 degrees, 2 degrees, 3 degrees, 4 degrees, 5 degrees, etc. Right? For any of those, so we've got an angle here for 25. We also looked at 60 a little minute ago. Right? We looked at triangles with a 60-degree angle as our focus. It doesn't matter how big that triangle is. If I take the opposite side of that triangle and I divide it by the hypotenuse of that triangle, for a triangle of 25 degrees at that point, right, what ratio did you get?
0.43.
So you got 0.43, yes? And there'll be more decimal places probably, right? But from 0.43, etc., is the ratio of these two sides. So mathematicians decide to, well, oh, you know what? Because 25 is the same for every one of those triangles, no matter how big or small it is, for that ratio, I'm going to give it a name. And we're going to call it sine. So if I take the sine of 25, so on your calculator, put in the calculator the function sine of 25. 0.43. You get this? Yeah. Now, there's got to be some subtle differences because of rounding.
No, it's supposed to be 2. I said.
Oh, is it meant to be a 2 here?
Yeah, not bad.
Okay, whatever it is, right? Someone decided that if I take the sine, this function, so the calculator takes the number 25, does this operation on it, and now the definition of this operation is actually quite complicated. In other words, how they do that little calculation, not going to go there, right? Don't need to. The calculator does its magic and comes up with this ratio. So that any triangle with a 25-degree right angle triangle with a 25-degree angle in it, the ratio of those two sides is that value every single time. Right? If I change the size of the angle, I change the ratio. But the calculator can work out what that ratio is. Now, why is that useful? Because it allows me to find information about that triangle that I don't already have. For example, okay, so let's move off. Now, we already know these ratios, okay? So let's have a look at an example, right? So on your books, could you draw this triangle for me, please? Okay, so on your books, can you just jot down that triangle, please? Now, I've deliberately chosen that angle because we've just been talking about it. It is 25. It's an X, and that's a 15. We all good? Cool. Okay, now, the reason that trig was invented was to allow us, well, because we know that all right angle triangles with a 25-degree angle here, the ratios of the sides, whether it be the sine ratio, opposite over hypotenuse, or the adjacent over hypotenuse ratio, which is cos, or the opposite over adjacent ratio, which is tan, will be the same no matter what. Okay, so I can find the sine of 25. Now, if you look at that triangle, what sides am I given? Right, so I'm given the hypotenuse, and what else am I given?
Angles.
Okay, what other side is marked? The adjacent. Is it?
Opposite side.
It's one of those. Which one?
Opposite.
This one's got a marking next to it, yes? So what side's this one? Opposite. How do I know it's opposite? It's opposite. No. Shh. It's not bad. This is what we want to clarify, yeah? So it's not a bad, mate, okay? The 25 degree is the angle that we're focusing on. The x is opposite that angle. So that's why it's called the opposite side. Okay? Now, mathematicians have worked out that if I've got the ratio opposite and hypotenuse, they've called that the sine ratio. Okay? And I know that the ratio of opposite to hypotenuse in a 25-degree angle is going to be that trig function, sine of 25. Okay? Now, they could have replaced this word sine with any word they wanted to. It's just a placeholder. Tangent has a particular meaning, and it's called tangent for a reason, okay? Because it's related to the angle created by the function to the x-axis. That's a grade 11 thing, right? So tangent has a separate meaning, so that's why that's called tan. But sine and cosine, okay, they are named that for reasons, but they could have really called it anything they wanted. They could have called it Trevor, right? It could be Trevor of 25. It could be Margaret of 25. It doesn't matter, right? It's just a name that they've defined that function to be. On your calculator, there are 3 buttons, sine, cos, and tan. They could literally be any words they wanted them to be. They just chose those 3, right? So, on your calculator, can you do that? Yes or no? Can you find the sine of 25 in your calculator? Right. So, to 4 decimal places, could you write that down, please? To 4 decimal places, what is the sine of 25? .4226, do we agree? Yep. So 0.4226. I can find that value. Do I know the opposite side, or have I got a label for the opposite side in this triangle? Yep. It's x, yes? So I don't have a number, but I've got a label. Do I know or have a label for the hypotenuse? Yep, what is it? 15. So notice the trig function says, I know what the ratio should be for this type of triangle. So the ratio of these 2 sides should be 0.4226. What number do I need to make that ratio true? Because the ratio for sine is opposite over hypotenuse. That ratio has to equal this. That's what that number is. It's the division of the 2 sides. But I don't know what one of the sides is. So how do I work out what x is? What does that mean? Yeah, so what operation? Plus, minus, times, or divide? Times it, yep. So I'm going to times it. So x is going to equal 15 multiplied by 0.4226. You might recall that in term 1, we spent a lot of time rearranging equations. This is the reason. I don't want you to get hung up on the math, on the algebra. I want you to be able to do the algebra. And you get 6.339, is that all? Yeah, it's exact. Okay, cool. Now, this is where we as a class are going to become a little bit intelligent and say, rightio, 6.339, in this case, centimetres. So first of all, before we go any further, are we okay with how we got 6.339? Yep, we will do more examples, but for this particular calculation, does that make sense? Right? Now, I'm not going to give 6.339 as my answer. The reason for that is if you look at the question, how accurate are the numbers in my question? Just said, well, no, it's 15 centimetres. How many decimal places there? None. So none. So is it reasonable then to put my answer to something that's really like 3 decimal places of accuracy? Right? Because this is centimetres, that's millimetres, that's tenths of millimetres, hundredths of millimetres accurate. That's just 15. I can measure that with my ruler and my pencil case. So what answer should I really give here?
6.3.
6.3 I'd accept. If you gave me 6, I'd accept that as well. Okay? I wouldn't go any more than 1 decimal place. In this case, I probably wouldn't do any. I'd just go to 6. Now, so therefore, why have I got 4 here? Because I need it. You only round off at the end. Okay? I only ever round off at the end. So I'm going to go with 6 as an answer, but if you wrote 6.3, I would accept that. Is that okay? Yep. So we're going to approximate my answer. That's what the wiggly equal signs means. 6 centimetres. Okay? So that's how the ratios work. The ratios allow us to work out what the value of the sides are. Okay, so let's do some practice. There's two triangles. You'll notice there are given angles there. In this case, we've got a B. In this case, we've actually got a value. So for question A, what's the trig ratio that relates the sides that were given and the angle that were given? And write that down as an equation. So if you're not remembering, I know it's small now, probably too small to see. Okay, so I'll make it. So first things first, label the sides. So for triangle A, label the sides. What are they? Don't call it out, just label them. What's the matter, Molly? Do you need to see a bit closer? Okay. First job, label the sides. So draw the triangle quickly, just for A. B is my reference angle. So this is the angle that I'm interested in, right? What are the sides? Yep. Hallelujah, just do that one first. Are we comfortable that B, 6 is the opposite side and 15 is the hypotenuse?
Yes.
Yep. So what trig ratio relates to those two? Sine. Right, so the sine of B is equal to 6 over 15.
Why not sine B?
What's my angle?
B.
Remember, in the rule, I'll go back up to it. In the rule, next to the trig ratio is the angle.
I thought you were just.
Well, you would if it wasn't labelled. But in this question, you notice the angle is a B.
But you're not actually going to put B in the calculator.
Well, we'll work out how to do that in a second. Okay, we'll go. All I want you to do is just write the rule. So do the same thing for question B. What would be the rule that you're going to use to solve this problem? So label the sides. Pretty obvious as to which angle we're referring to. It's the 50 degrees there. Label the two sides, given that angle, and then what ratio? For the moment, mate, yes. We're not going to solve it yet. We will in a minute. But for the moment, I just want you to write what rule would you use to solve it, and then we'll worry about solving it in a minute. Okay? So, yeah, we'll come back to it. But for the moment, let's just get the rule right. What's the matter, Molly? We'll get to that. Don't panic. We will.
That's not sine.
That's right, it's not. That's right, it's not sine. How do you know it's not sine?
Because sine, you have to have the angle.
No, you have to have the hypotenuse. So what are the two sides that I've got? What's the x?
Opposite.
It's opposite.
And adjacent.
Oh, yeah.
Right? We've done A. The question, Molly, the question just says what's the rule? Doesn't say solve it. We will come back and solve it in a minute. I just want to make sure we pick the right rule first. We don't pick the right rule, we can't solve it. So what ratio links opposite and adjacent? 10. Now what's the angle in this question? 50 degrees, so it's going to be tan of 50. And what's the ratio for tan? Adjacent, right? So opposite over adjacent. So my opposite side in this case is x. My adjacent side is 18.
You can't do that on a calculator.
Yes, you can. We'll teach you how in a minute. All I want to practice at the moment is getting the right damn rule down. Without the right rule, we can't solve a thing. Okay? First of all, are you okay how we got to that? Yeah, we're not going to solve it yet. We'll come back to that in a minute. So, It's exactly the same. Yes, it is. Okay. Shh. Okay. You who? Because I've had to zoom it in, I'll explain what the question's asking you to do just for this one. Okay, for this triangle on the board, what I want you to do is for the given angle, in this case we don't know what it is, right? I want you to write down, if you were asked to find the sine of theta, what two sides and what would the ratio be for sine for that triangle? If you did cos of theta, what would be the ratio? And if you did tan of theta, what would be the ratio? Okay, so have a go at that. So remember, sine is what ratio? What's the ratio for sine? Opposite over hypotenuse. What's the opposite side? What's the hypotenuse? Write it down as a ratio.
There's no point doing that, because we already have all the sides.
Just do it anyway, because it leads me to something we're doing shortly. Okay? Yes, that's what we'll be working towards. That's exactly right.
You only do one angle.
That's right, but I want to prove you something. Yes. Yes, and you should get the same answer every time, is the point. Guys, focus. I don't even know about your bathroom habits.
Greg, how's your leg?
So what are all sin, cos, and tan?
Yeah.
Because I want you to write all three ratios to prove something that we're going to do in a minute.
I say soft, so
One of those is wrong. Shh. Deliberately. Deliberately, one of those is wrong. Which one? And fix it.
What's called? It's called
So think of the rhyme. Think of the rhyme. Sokotoa.
Hands wrong.
Is it soft or
SOHCAHTOA.
Oh, hands wrong. That's one way.
Yeah, Greg.
I just want to flip in different ways.
So which one's wrong? Tan's wrong. Okay. Gentlemen. So, are we okay that those would be the ratios for that triangle?
Yeah.
Okay, now, questions were asked multiple times. Why am I writing all three? Okay. Riley answered it beautifully. He said, because I want to make sure that you can actually find all three different ratios. That's the first reason. The second reason is, I'm going to go back and now solve the questions that we've been talking about. So let's go to the second one first. So let's go to that, which was triangle B. Could you please work out what x is equal to? For that ratio, what's x? You don't need to. We've already done that. It's opposite. It's up there on the board. Opposite over adjacent. So I've already done that. We've already identified that. So first job. First job is find the tan of 50.
Show the second decimal.
I want to check copies out.
Yeah.
Is it? What's the little swap thing and
We'll get to a question like that, Molly. We'll get to a question like that shortly.
Is the test like super long this time?
No, let's not worry about it now. All right, let's not, no, it won't be super long. It's 90 minutes. Shh, gentlemen. So to solve that one, first thing you do, because you know 1050, well, you've got all that information on the left-hand side, you can type that into your calculator. 1050 equals, to 4 decimal places, you should get 1.1918. Then you solve for, no, it's not. It's what? What? Where? Okay. Do you recall a few minutes ago, and I'm not being smart, but do you recall a few minutes ago that I gave you this triangle and said, tell me what the ratio is?
Yeah.
So that was the first step of solving this problem. Right? Now I've come back to it and gone, well, how do I solve this? So this is what I'm doing now. Darren, this is what we're doing now. I'm teaching you how to solve this problem. So we want to know what x is. Right? So, are you okay with how we got that information?
Yeah. Yeah.
Tan of the angle is opposite over adjacent. The opposite side is x. The adjacent side is 18. You cool with that? Yep, right. So, the unknown's over here. Right? First thing I do, can I find this value? Well, yes, I can. Literally type in your calculator. Tan 50 equals. You get that? Yep, right. So I'll write that down. Now it's just algebra. How do I get x by itself? This is being divided by 18. Opposite of divide is times. I've just swapped the sides. Yeah.
It's actually 20.
No, it's 21.
It's 21.45.
No, but you don't.
Oh, okay. Let me just try something. Coops, to see if I think what you're saying to me is what you're saying to me, okay? Just bear with me for a minute.
It's 21.45.
I get the same thing, but if I go 18 times 1.1918,
No, so it's because he's rounding up the 5 to the 4, which means the 4.
don't round up twice.
Yeah, that's all right.
Yeah, so you've rounded the 5 to 4, then the 5 up, don't do that. Right? So, if you're rounding off to 1 decimal place, then you use the second one and round it, so that would become a 5, correct? That's where you stop. But if you're rounding off to a whole number, you look at that number, doesn't matter what comes after it. Does that make sense? Yep, okay.
285.
Alright, now,
Yeah, that was
damn it, okay. Could you please do these questions?
That's pretty rich.
That was actually good.
Nice. Could you please